Hello, this is Mr. Stansbury. I'm going to take you to the last section of Chapter 11, which is the last chapter in the first year of IB studies. Yay! So anyway, this is on 11I, harder applications. The goal on this is to be able to say that I can use various formulas and strategies to solve more difficult real-world type problems. And I'm going to show you just one example, but it pretty much puts together this entire chapter with a whole bunch of different questions on the same piece here. So this is example 2. This is actually number 2 from page 390 because they didn't actually give us any examples to go through. So this is number 2 from the assignment, or from the book assignment here anyway. And it says a feed silo is constructed out of sheet metal that's 3 millimeters thick. And it says show why the depth, or the height in this case, of the cone must be 70 centimeters, and then find the slant height of the conical section. Conical section just means this here, the cone piece of this silo. Okay, so first thing we want to do is start trying to figure out what these dimensions are here, because we got to be able to show that the height of this cone here is supposed to be 70 centimeters. So let's kind of draw some more. Let's draw this a little bit more three-dimensionally here. So if you were able to see through this, it would look kind of like that here. And they're saying that we want to know that this here, this height here, has to be 70, 70 centimeters, not meters. Right? So, let's see. We will want to figure out what this is here. This is this top piece here is, I didn't really draw it very beautifully, but it's supposed to be a half of a sphere. So if it's a half a sphere, oops, this radius here, which is apparently crooked, that's alright. This radius here should be half of this diameter, and we know the diameter is 1.6. So really what we're going to want to do is take 1.6 and divide it by 2, which gives us 0.8 meters. So we know that this diameter here is 0.8 meters, which is, if we move the decimal over twice, it turns it into 80 centimeters, right? Okay, let's stick with 0.8 for now, but we'll use the 80 here maybe in a little bit. So we have this from top to bottom, it's 3.3 meters, and we know that this piece is 1.8. So we can do this. We can take 3.3 and subtract 1.8 to get 1.5, and that's this piece and this piece. We just figured out that this is 0.8, so if we take 1.5 minus 0.8, that leaves us with 0.7 meters, and 0.7 meters, they say that it needs to equal 70 centimeters, and guess what? Meters to centimeters, move it over twice to the right, and we get 70 centimeters. So we have now shown why the depth, or the height of this cone, must be 70 centimeters. And now, since we know that, find out what the slant height of this conical section is. So basically they're saying figure out what this length right here is. Okay, so again we have this here. We know that this is a right angle. So let's see, we know that this here is 0.8 meters, this is 0.7 meters. So if we're to redraw just that piece there, we would have that this is crooked, but that's alright, you're used to it by now. 0.8 meters, and this is 0.7 meters. So we should just be able to do a squared plus b squared equals c squared, right? So 0.8 squared plus 0.7 squared should equal this hypotenuse, or the slant height, squared. Alright, so we turn on our calculator, and 0.8 squared plus 0.7 squared gives us 1.13. And then we just want, so we got c squared equals 1.13. So then we will square root both of those and get that our slant height is square root our answer, and we get 1.06 meters. So let's go with that. 1.06 meters is our slant height for this here. Okay, so we have finished off A. Let's take a look at B. It says calculate the surface area of each of the 3 sections and show that the total steel needed is about 15.7 meters squared. Excuse me. So it's at least nice because they give us the answer in there, just saying make sure that you can get that all figured out, right? So let's see. We have the 3 sections. We've got the half sphere here, we have the cone here, and then we have the cylinder here. So I don't know about you, but I think I'd rather let's find the cylinder first. So, and again, you can do it however you want, but the surface area of a cylinder is basically, if you think about it, you cut the cylinder, like just snip it, like think of it as a tin can, snip it down here and open it up, flatten it out, and that surface area is going to be the base here, which is basically the circumference. So surface area is the circumference times the height, or the surface area circumference is 2 pi r times the height. So our surface area of just this piece here is going to be 2 times pi, and again we know that the radius of this thing here is 0.8, and we know the height is 1.8. So bring out our handy dandy calculator again, and let's see what we get. 2 times pi times 0.8 times 1.8 gives us 9.05. Let's go with 9.05, and this is all in meters, so meters squared, so that's just for this part of the can here. And now we're going to need some other formulas here. One of the formulas is for the cone here, and that says area equals pi r times s. So pi times the radius times the slant height is going to be the surface area of this cone. So this is the cylinder part. Alright, now we're going to do the cone part. And then the surface area of that is, again, pi times the radius times the slant height. So pi r times s. So in this case, surface area is pi times, let's see, the radius, again, is 0.8, and the slant height is 1.06. So we use our calculator here. We do pi times 0.8 times 1.06, and that gives us 2.66 we'll go with. And that is also square meters. Alright, and then next thing we're going to have to do is find the area of this half sphere here. And so we need to know the area of the sphere. Area of a sphere, and again that says minus, there's supposed to be another little line there, equals 4 pi r squared. So the little half circle thingamabobber here is going to be, since it's only half of the sphere, let's do half of 4 times pi times the radius squared. So in this case, we get half 4 times pi, and then again the radius is 0.8 squared. So the surface area on this one is going to be 0.5 times 4 times pi times 0.8 squared. Alright, and that gives us 4.02 square meters. Alright, so to figure out the total surface area, we just add all 3 of those together, right? So total is going to be 9.05 plus 2.66 plus 4.02 2. So let's try that out. 9.05 plus 2.66 plus 4.02, and we get 15.73. 15.73 square meters, and we were supposed to show that it's supposed to be 15.7, so we know we got that one right. That's a doozy. That's a good question. That is certainly not something that's really easy. You're gonna gotta take little piece by piece and go through and solve that. All right.